Equation for a geometric sequence. Okay, so let a sub n be the nth term of a geometric sequence with first term a sub 1 and a common ratio r. The nth term is given by that equation. Now, we've kind of already talked that a geometric sequence is really just an exponential pattern. So when we did linear and we did arithmetic, we could revert back to y equals mx plus b, or we could use the formula they gave us. We can kind of do the same thing with geometric, but it's a little more confusing. So the first example, I'll go through both of them, but really, this is the formula that we're going to use. Now, keep in mind that a sub n is really just like saying y, a sub 1, and then r is your common ratio, and then to the power of x minus 1. So really the n is just a variable for x, the a sub n is a variable for y, and then a sub 1 is the first term, and r is the common ratio. Okay, and when we compare this to the formula that we know, remember the formula that we know is y equals a times b to the x power. So we'll look at both of these, but you're going to see me revert back to this one because when you're dealing with geometric sequences, it's just going to be easier. Example 3. Write an equation for the nth term of the geometric sequence and then find a sub 7, which means the 7th number in the pattern. So first things first, if we're going to write these out, I'm just going to go back to my table so we kind of have something to look at here. This is 1, this is 2, this is 3, this is 4. And then we have to find our pattern or our common ratio. So if I want to get 1 to negative 5, I would multiply by negative 5. If I want to get 5 to positive 25, I would multiply by negative 5. If I want to get 25 to negative 125, I would multiply by negative 5. So first of all, this is r, which is our common ratio, multiply by negative 5, multiply by negative 5, multiply by negative 5. So we've got a sub n equals a sub 1 times r to the power of n minus 1. A sub n is your variable. It's just like saying y equals. A sub 1 is the first term of the pattern. Well, the first term of the pattern is 1. Times, always use parentheses here, okay? R is your common ratio. We're multiplying by negative 5 to the power of n minus 1. Then if we want to clean that up, we've got a sub n equals. You don't really need a 1. You can leave it there. I won't mark it wrong. Negative 5 to the n minus 1. And here you have to have parentheses because this whole thing is being raised to a power. Don't drop your parentheses. That is your formula that will give you any number in the pattern. Now, on the flip side, and I'm only going to do this on this first example because I honestly on geometric find this more confusing. In the past, we've done y equals a times b to the x. Well, that's y equals a, and keep in mind that a is your y-intercept. Well, your y-intercept means back here in the table, we have to go back here to 0. Well, if I'm multiplying by negative 5 to get this way, that means I have to divide by negative 5, which is going to get me negative 1/5. So my a value is going to be negative 1/5 times b, which is my common ratio, which is still the negative 5, to the power of x. Remember, when you're doing this, you may not multiply these two together. Okay, same idea. We didn't multiply these two together. We just didn't need the 1. So this would be the other version of what's going on here. Now, these don't look the same like they did with the arithmetic, which is again why I don't like to do both of them. I'm just going to stick with this one over here. But to show that they're the same, it says to find the 7th number in the pattern, which means we're going to substitute in 7. So over here, a sub 7 is negative 5 to the 7 minus 1. So a sub 7 is negative 5 to the 6th power, because we have 7 minus 1. So negative 5 to the 6th. I'm going to go grab our calculator. Desmos.com. I'm just going to grab a scientific. Make sure you're using parentheses to the power of 6, which is 15,625. So we know that this is 15,625. Now, let's go see what we get when we use our other formula. So here we're going to have y equals negative 1/5 times negative 5 to the, remember we're finding a sub 7 to the 7th power. So y equals, and then I'm just going to go grab my calculator. Negative 1/5 times negative 5 to the 7th power. And notice we get the same thing, 15,625. So either method will work here, whether we use our new geometric sequence formula on the left, this a sub n, or if we use our y equals a times b to the x. Just make sure you know what you're finding for each one. But from here on out, I'm just going to stick with the one on the left. Letter C. Write the equation and then find the 7th number. So the first thing I'm looking for, one, two, three, 4. We have a sub n equals a sub 1 times r to the n minus 1. How do you get from 13 to 26? You multiply by 2. 26 to 2, multiply by 2. 52 to 104, multiply by 2. So a sub n equals the first term, which is 13, times the common ratio, which is our 2, to the power of n minus 1. And again, this could be a y, this could be an x, it really doesn't matter. But that's as far as you can go. You cannot multiply the 13 and the 2, leave it alone. Now we want the 7th term. So a sub 7 equals 13 times 2 to the 7 minus 1. That's going to be 13 times 2 to the 6th. Grab your calculator. 13 times 2 to the 6th is 832. So that tells me if you were to extend this 1, 2, 3, 4, 5, 6, 7, the 7th number would be 832. Letter B, I'm going to start the same way by kind of making my table. And then we've got a sub n equals a sub 1 times r to the n minus 1. How do we get from 432 to 72? I think this is multiplied by 1/6. 72 to 12 multiplied by 1/6. 12 to 6 multiplied by, 12 to 2 multiplied by 1/6. So a sub n equals a sub 1. That's the first number, which is 432. Times my common ratio, that's the 1/6, to the n minus 1, that's your formula. Then we want the 7th number in the pattern, so a sub 7 equals 432 times 1/6 to the 7 minus 1, which is 432 times 1/6 to the 6th. I'm just going to clean that up. grab your calculator. 432 times 1/6 to the 6th is 1/108, which if you're using a different type of calculator, please use Desmos, but you're going to get like 0.00925 or something like that. Don't give me that decimal. I want the nice neat fraction. Okay, last one of these. Again, pause the video, try it on your own, then when you're done, come back and see how you did. One, two, three, 4. Okay, so a sub n equals a sub 1 times r to the n minus 1. I'm going to go back up. I'm going to try to find a pattern. This one looks kind of hard. 4 to 10, 10 to 25, 25 to 62.5. This is not a pretty number. So let's see. If I take 10 divided by 4, I get 5 halves. So 4 times 5 halves is 10. Okay, let's try that again. 10 times 5 halves is 25. Okay, I'm going to try it one more time to make sure it works. So 25 times 5 halves is 62.5. Oh, wow. Okay, and the way I found that out was I took 10 divided by 4, which gave me 5 halves. So a sub n equals a sub 1, first number in the pattern, 4, times common ratio, 5 halves, to the n minus 1. Then we want the 7th number in the pattern. A sub 7 equals 4 times 5 halves to the 7 minus 1. So a sub 7 equals 4. Remember, don't multiply the whole number in the fraction. You can't do it. The only thing you can do is the 7 minus 1, which is 6. So 4 times 5 divided by 2 to the 6th is, wow, 15,625 over 16, which if we make that one into a decimal, you're looking at roughly 976.5625. And the reason I'm kind of okay with that is because you notice here they started using decimals. So if they start using decimals, you can make an argument for you using decimals. If they don't use decimals, you better not use decimals.